Hello everyone, welcome to test review day 2. Just like yesterday, our goals are going to be the same here. Our goal is to get ready for the test, which is going to be Wednesday, Thursday, and Friday this week. The focus of the review today is going to be functions and domain and range. Right. So again, this is a review, so you should feel free to fast forward to whatever parts of the video you feel like you need most. I'm going to be going over quite a bit, so if you feel like, hey, I don't really need to see and evaluate and solve functions problem again, I'm good on those, you can fast forward to the part of the video that you feel like you need to see, and then make sure you go do the practice problems to make sure that you know what you know. All right. You might think you know evaluating and solving functions, and then go to the review and realize like, oh, maybe I should watch that video, or I should watch that part of the video again. Okay, so that's how I want you to use the review. All right, so I'm going to go ahead and get started here, and the first thing we are going to talk about is evaluating and solving functions, right? So remember, a function has inputs and outputs. So with these, they're going to give you a function rule, and then they're either going to give you an input or an output, and you have to solve for the other. Okay, so in this first one, our function is the square root of x plus 2, and that plus 2 is outside of the square root here. And they're asking us to find f of 4. So they're telling us an input is 4. All right, so we're going to take that 4 and I'm going to plug it in wherever I see an x. All right, so what we're going to do is we're going to say f of 4 equals the square root of 4 plus 2. Okay, so that x got replaced with our input. And then I just go through and I evaluate, right? So the square root of 4 is just 2. So now I have 2 plus 2, and 2 plus 2 is 4. So when I put a 4 in, I got a 4 out. All right, so let's try the next one. This one's a little bit different because the number that they give us is not inside of the parentheses here. So in this case, the 5 is the output of the function. So they're asking us to take the output and find the input. They want us to find x. So I'm going to take my rule, the square root of x plus 2, and I'm going to set it equal to 5. I want to get a 5 out. So this becomes like an equation. I got to draw a line, and my goal is to figure out what x is, so I've got to get x by itself. And I'm going to start with this 2. I'm going to subtract 2 on both sides of the equation. So the 2's will cancel, and now we just have square root of x equals, and then 5 minus 2 is 3. And since my x is trapped inside of a square root here, what I'm going to do is I'm going to undo the square root. I'm going to take both sides of this equation and I'm going to square, right? Because that's the opposite of square rooting. So I'm squaring both sides of the equation. The square root and the square will cancel each other out, leaving me with just x, which is what I wanted. And then over here, I would do 3 squared, which gets me 9. And there's my input, right? So if I were to come back to my rule here, right, if I did the square root of 9 plus 2, well, the square root of 9 is 3, and 3 plus 2 is 5. So I can see that my input works to get me the output they wanted. Okay? And that's something that you can always do on the test. You can always take whatever your answer is and plug it in and see if it does in fact get you that output. So it's a way of checking yourself and seeing if you got it right. All right. All right, so another big part of the test, we've seen this on just about every quiz so far, is describing graphs, including domain and range, right? So I would give you a function. I'm going to ask you to graph that function. We'll use our calculator to do that. And then we want to describe all of the important points, right? So x-intercepts, y-intercepts, vertexes, if it has one, minimums and maximums, if they have a minimum or a maximum, and then also describing domain, range, and the line of symmetry. So we'll go through each of those after we get this thing graphed. All right, so I'm going to pull up my calculator here, and that should be your first step, is to get your calculator up and going and getting this function into the y equals screen. Okay, so the first thing I'm going to hit here is y equals, and then I'm going to type in my function exactly as I see it here. So I'm going to start with a parenthesis, and then I've got x plus 2, and then they want to square on the parentheses, so I'm just going to hit the square button, just like that, and then minus 4. All right, so I'm just going to double check it here and make sure that it looks exactly the same as it does on my paper, and I don't see any differences here. Okay, so I'm going to go to the graph and see what this thing looks like. Okay, so when I create my graph over here, I want to make sure that this graph and this graph match up, that they're the same graph when I'm done. Okay, and when you do this on MyOpenMath, the first point that you click on when you go to the graph, the first point that they want you to click on is the vertex. So I want to figure out what this point is right here. I also notice that's the lowest point on the graph, right? So if I go to my table, I can find that point by going to the y column and looking for the smallest number. And I notice that happens at -2, -4. Right? It doesn't go any lower than -4. So I go to -3, -4, but then I go back up to the -3 and I'm going back up again as I continue. So -2, -4 would be that minimum or the vertex of my parabola. So I'm going to plot that point first. And then on MyOpenMath, the second point that you click can be any other point that's on the parabola. So you can choose literally any point from this table. You might want to pick one that fits on the graph, so maybe you go to 0, 0 for your next point. Right? I see that right there on the table, so I know 0, 0 is going to be another point. So on MyOpenMath, you would click on the vertex, click on your second point, and it'll automatically form the parabola for you. Okay, so for the interest of getting this thing graphed here by hand, I'm going to grab a few more points just to shape out my parabola and get this thing going, right? So I'm going to plot a few more points here. There we go. So that should be enough right there to get my parabola going, and I'm going to try my best to draw this thing. I suck with this pen. There we go. So we should get something that looks like that. All right. So let's start going through our important points. Now that we have this thing graphed, let's start going through our important points. Also notice when you look at the graph on the calculator does not put arrows over here for you, but if you were to zoom out on this thing, this parabola would never stop going up. Okay, so when you make your graph by hand, if we ever get back into the classroom and we make these things by hand, you're going to want to make sure that you put arrows on the end to indicate that it keeps going. All right, so let's go through these important points real quick. X-intercepts, right? We're looking at the x-axis. Where do we hit those? Where do we hit the x-axis? We hit it at -4 and 0. But make sure you write these as points. So it's -4, 0, that's the location of this point, and the other one is at 0, 0. And you want to separate those with a comma. So make sure they're two full points with parentheses and an xy coordinate. All right, the y-intercept, here's our y-axis. We're looking at where we cross over or touch, and that happens right here. So that's going to be at 0, 0. Okay. Remember x, y with a set of parentheses. Okay. The vertex, we actually, that was one of the first things we found when we made our graph because we needed the vertex to plot on MyOpenMath. So we have that right here at -2, -4. Hit that one. And the vertex is also our minimum. We had said before that's our lowest point, right? So the vertex and the minimum are the same thing here. Now the maximum would be the highest point on the graph, except we know that this parabola keeps going, so there is not going to be a highest point. So we would simply say DNE. Right? There's no maximum. Right? The range of this function. Okay, so we have to kind of think it's a parabola. It keeps going up and to the right forever and ever, and it keeps going up and to the left forever and ever. And when we find the domain, we're trying to figure out how far to the left we can go and how far to the right we can go. Well, if it keeps going up and to the left forever and ever, well, it's going to go off to -infinity. Same thing on the right. If it keeps going up and to the right forever, it's going to go off to +infinity. Okay? And since we can't get to infinity, we put curved parentheses on both of those. So this would be a domain. It's essentially a way of saying all numbers, right? From -infinity to +infinity, we can put in any value of x that we want. Now the range is low to high, right? So how low does it go? How high does it go? And it's a way of describing all of the y values or all of the outputs of the function. So we start with low. Right? And we had already determined before that the lowest point was down here, and since I'm looking at y values, I'm going to go over to the y-axis here, and I'm looking at how low does it go on the y-axis, and it goes as low as -4. So I'm going to start with my -4. And then I say, okay, well, how high does it go? And we had already mentioned this before, but the arrows indicate that it keeps going up forever. All right, so it's going to go from -4 to positive infinity. The parabola actually does touch at -4, so we're going to put a square bracket on the -4 and then a curved bracket on the parenthesis. All right, line of symmetry, let me grab a different color pen here. And the line of symmetry is, if you can imagine, a fold line, right? So if I were to take this parabola and fold it somewhere so that one side of the parabola landed on the other side of the parabola, the line of symmetry would be the crease that is created when you make that fold. Okay, so where would you fold this thing? You would fold it right here, right down the middle of that parabola. Okay, so this is where I would fold my graph, and if I did fold right there, this left side would land right on top of the right side. Okay, and we look for where that line of symmetry hits the x-axis, and it hits at x equals -2. So that's how we write our line of symmetry. It's got to be an equation, it's going to be an x equals, and it is wherever the line of symmetry hits the x-axis. Alright guys, so that was a good comprehensive review of describing a graph. I want to do one more domain and range problem with you. So again, I talked about it in the previous problem. Domain describes the x values that go into the function. So we're looking at how far to the left and how far to the right a function goes. So if I were to jump on this curve that they give us here, right, and I started going off to the left, I would keep going off to the left until I stopped. And it looks like we're stopping here. And since we're looking for x values, I'm going to go and look at where I'm at on the x-axis. So I'm at -3 on the left. Okay. And then I would say, okay, well, how far to the right could I go? So I start going right on my function, and I notice there's an arrow here, which means it keeps going forever and ever off to the right. So that means it's going to go to positive infinity. All right. Now, closed dot here on the end indicates that I can actually get to -3. So I'm going to put a square bracket on the -3. And we've already discussed this before, but you can never get to infinity. So we need a curved parentheses on the infinity. All right, now range is up and down, right? It's a way of describing all of the y values that a function can get to. All right, so that since y values are elevation, right? It's up and down. We're really asking ourselves, how low does it go, and how high does it go? All right, so I'm going to hop on my function and I'm going to go down. Okay. And I'm just following my function, and I know it's going down, and then I get here to the arrow, which would indicate that it keeps going down forever. Even though the graph gets cut off, it keeps going down. So I know that this is going to go down to -infinity. So I'm going to go the other direction. I want to go up. I want to see how high I can go. So I follow my function up until it stops, and it stops here. And then I go over to the y-axis, and I see where I'm at. So I'm at +3. That's as high as this function will go. So I'm going to put a curved parenthesis on the -infinity and a square bracket on the 3. Okay, so it's telling me that y values can be anything from -infinity to 3. X values can be anything from -3 to positive infinity. Right. So there's your review on domain and range. Let's move on to modeling functions. Okay. So the way that these kind of problems are going to start, they're going to give you a scenario, right? So this is a situation, and you need to take this situation. It's a common everyday situation, and we want to turn it into one of the 3 representations that we have been learning about: equation, table, graph. Okay, and that's what it means to model. We're taking something that's happening in real life, and we're using mathematics to model it so that we can analyze that situation. Okay, now it tells us that Janora here starts with $200 in her piggy bank and is adding $150 per month. Okay, so they're giving us a starting value, and they're giving us a rate of growth. Right? And in the previous lessons, we had talked about situations where we're growing by the same amount each month creates a line. And the general equation of a line is y equals mx plus b. Right? And you probably remember this from Algebra 1. Okay? So m represents the slope, right? It's the rate of change, right? So how much money are we adding every month? And that is our slope. So I'd go back to the problem, and I remember it saying, well, they said they're adding $150 per month. So there's my slope. Now the b value on the end, this is our y-intercept, but in the context of a problem, the y-intercept represents how much you start with. It's like a starting value or an initial value. And I remember in the problem that it said she starts with $200. So I now have m and I now have b, so I can complete my equation. So I can say y equals 150x plus 200. There's my equation. Now watch what I can do with the equation. Now that I have an equation, I can generate a table. So for instance, I can plug a 0 in for x, and I can evaluate. 150 times 0 is 0. 0 plus 200 is 200. So I know when I put a 0 in, I get a 200 out. And then I would do the same thing for each of these inputs. I would then go plug in a 1, see what I get. Plug in a 2, see what I can get. Okay, so I'm going to fill in those values, right? And this is what you should get. Okay, so we go 200, 350 to 500, right? We're adding $150 a day, so every time I add 150, right? That's what we should get. And then I'm going to take this table and turn it into a graph. So I'm going to pick some points here. I'm going to do 0 and 200, which will be located right here. The next point is at 1 and 350, which is located right here. And then 2 and 500 should be right here. And 3 and 650. And then 4 and 800. And we start to see our graph taking its shape. It looks like it's creating a line for us. So I'm going to draw in a line on top of those points. There we go. And there's my graph, right? So I took a situation, I modeled it with an equation, a table, and a graph. And you'll see something similar to that on the test here. All right. So last one here, let's take a look at one more modeling situation. And you'll notice in this one, I only ask you to create a table and a graph. That's because this situation is not a linear situation. It's a different kind of function, and we will talk about how to write the equation for a situation like this in the future. Okay, so it says Janiora is saving money in her piggy bank again. She's going to start with $50 in her piggy bank. So that means before any time has passed, she's going to have $50 in the piggy bank. So she's starting with 50. And then it says the amount in her piggy bank will double each month. Okay, so we want to create a table and a graph to model this. So if she doubles the amount of money in her piggy bank each month, right? So 1 month goes by, we double the 50, and now she has $100. Another month goes by, we double the 100, now she's got $200. Okay, we do it again, we double 200, we'll have $400. And then if I double $400, we'll have $800. Okay? So I just took a situation and I turned it into a table, and now I'm going to graph this thing and see what it looks like. So I'm going to go here, and remember she started at 50, and then it doubled. So after 1 month she's at 100, and then after 2 months she's at 200, and then after 3 months she's at 400, and then after 4 months she's at 800. There we go. And we start to look at this one, and we might ask ourselves, well, this is certainly not a line. It's not like the last one. It's a curve of some kind, and so it's got a little bit of a different behavior. And I'm going to go ahead and draw that curve over the points, and then I'll put an arrow here to indicate that it keeps on going forever and ever. All right. So there we go. So now we've got it modeled, and the question would be, which piggy bank would you rather have? And this is completely up to you. You've got to look at the graph and the tables and really think, which piggy bank would you rather have? And I would suggest that you think beyond month 4. What would happen if this thing kept going compared to what would happen if this thing kept on going? Which piggy bank is eventually going to be worth more money, right? Because you want to make sure, if you have to pick between the two piggy banks, which one you would want to pick, the one that has the most money. All right, so use what you know from the table and the graph, and you can extend the table. So you could go to month 5 if you wanted to, month 6, and really see what's going to happen as these piggy banks grow. Okay. All right, guys, that's it for today. That completes the review. Hopefully that was helpful, and good luck on your test.